Hi, this is Bob Pryor. I'm going to talk to you today about points in the XY plane. And we're going to start by graphing a parabola. This is in preparation for graphing trig functions later on. The function we're going to graph right away, y equals x squared plus 2x minus 3. And as you can see, we're asked to find the line of symmetry and the vertex of the parabola. Usually a good x value to choose right away is 0. So let's see what we get when we put 0 in. We'll just kind of do this quickly. Our ordered pair is 0, negative 3. Let me move this up a little bit. 0, negative 3. Okay. And let's try x equals 1. 1, 0. Good. And let's try x equals 2. 2, 5. It doesn't look like we're going toward the vertex as we go from 0 to 1 to 2, so I'm going to do negative 1 and see where that gets us. Negative 1, negative 4. I think we're about to turn the corner. Let's just do one more, and that will give us some good information. X is negative 2. Negative 2, negative 3. Okay. We finally have a point of symmetry. We have the point over here, 0, negative 3. And on the left side, negative 2, negative 3. That means the graph is starting to turn around, and that actually tells us our line of symmetry. Let me draw it in. Okay, and then the wonderful thing about the line of symmetry is that we don't need to actually continue choosing x values and finding the y. We can actually use the graph to help us identify other points. For example, this point here, which is at 1, 0, is a distance of 2 from this axis of symmetry. 2 on the right, well, we'll go 2 on the left, and we'll find another point. And of course, we're able to do that without having to actually choose an x value. Let's do that for the point 2, 5 as well. That's 3 away to the right, so let's go 3 away to the left. And that point is now negative 4, comma 5. And I think we have enough points where we can draw in the parabola. Let's do that. It's not beautiful, but we get the idea. Let's see what's next. The distance formula. Well, we're familiar with this formula from algebra. This is distance between 2 points in the xy plane. And we've got the point x1, y1, x2, y2. And here's the formula. Okay, the equation of a circle centered at the origin. Over here we can see a circle centered in the xy plane, centered at the origin, 0, 0, radius of r, and I've just chosen an arbitrary point xy to be on that circle. Now the equation we see right here, x squared plus y squared equals r squared. And where does this come from? Well, the distance formula. We're talking about the distance between 2 points. The point xy and the point 0, 0. We can see here where our distance is r, the radius, and using the points xy and 0, 0, placing those into the distance formula, r equals the square root of x squared plus y squared, square each side. Lo and behold, the equation of a circle centered at the origin. We can just as easily write that as x squared plus y squared equals r squared. So let's apply that to graphing a circle. Circle centered at the origin, passing through the point 4, negative 3. Let's find that point 4, negative 3. What we're asked to do first is find the radius of the circle. there's a hint here that says use the distance formula to find the point between 4, -3 and the origin. Okay. So the radius r is square root of 4 minus 0 squared plus -3 minus 0 squared. And we can simplify that using order of operations. R equals the square root of 4 squared plus -3 squared. R equals square root of 16 plus 9. That's R is square root of 25. And of course, R equals 5. This means that the radius from the origin to that point is a length of 5. The question is, how do we find more points on this circle in the graph? Well, we have actually a lot of clues here. I'm going to start with the radius of 5 and use that radius along the x-axis and the y-axis. 5 to the right, 5 to the left, 5 up, and 5 down. Okay, but it would be nice to have a few more points. Well, the wonderful thing about a circle is that there's tons of symmetry. For example, using our point 4, -3, if we go straight up from there across the x-axis, we get the point 4, +3. And from here, if we come straight across the y-axis to -4, +3, we have another point on the circle. And straight down from there across the x-axis is -4, -3. And we actually get a full another set of points where we have 4, 3. We also have 3, 4, another point of symmetry. And we can do that all the way around the circle in each quadrant. So we have plenty of points for which to draw our circle, and now's a good time. It's not going to be beautiful drawing on this screen, but you understand. That's not so bad. Next question is, what is the equation of this circle? Well, remember, the equation of the circle that's centered at the origin is x squared plus y squared equals r squared. And the radius here is 5, so x squared plus y squared equals 25. And there you have it. In trigonometry, an extremely important circle is called the unit circle. And we see here that it is centered at the origin and has a radius of 1 unit. That's why it's called the unit circle. It could be 1 foot, 1 inch, 1 meter, 1 centimeter. In general, just 1 unit. When we want to draw the unit circle, all we need to do in the xy plane is come out a certain distance and just label that as 1. And then try to do our best to be consistent with 1 around the x and y axes. So we'll say this is 1 here, and we'll label -1 on the left and -1 down below. And then we'll use our very best drawing skills to draw in the unit circle. Well, we won't use our very best drawing skills. That's really awful. That's not so bad. So what is the equation of the unit circle? Well, remember, we have x squared plus y squared equals r squared. And in this case, r is equal to 1. So the unit circle equation is x squared plus y squared equals 1. Congratulations to us. Well, I hope this makes sense, and if you have any questions, be sure to ask. Thank you. Bye-bye.